Hello dear students. In previous videos we have seen unit number 1 matrices and system of linear equation. In this video we are going to see mixed examples. So some example will be based on finding the rank of given matrix and some example based on solving system of linear equation by Gauss elimination method and by Gauss-Jordan method. So let us see very first example. Find the rank of the matrix. First row is 1, 1 and second row is A, A. So let us see solution. So we can take this matrix as A. So let A is equal to row wise 1, 1, A, A. Now we have to reduce this matrix to echelon form. So apply which transformation. So we have to A11 is already 1. So we have to make all entries below A11 equal to 0 by using R1 row only. So here is 1 and this R2 row first entry is A2. So you can just multiply this R1 row by A and subtract from R2. So you can apply R2 minus A times R1. So this matrix is equivalent to first row as it is. This transformation will change the entries in R2 row because R2 is at the first position. So you are multiplying this row by A. So you will get this at this position A minus A is 0. Likewise, A minus B is equal to 0. And now this matrix is in echelon form. Why this matrix is in echelon form? 0 rows appear at the bottom of matrix and only one non-zero row. So no need to check second condition. So which is in echelon form. Which is in echelon form and therefore rank of matrix is, what is that? Number of non-zero rows. So only 2 rows are there, out of them one is non-zero and one is 0. So we have to count only non-zero rows. So rank of matrix A is 1, or you can denote this by like in this notation, a row of A is 1. So this is quite simple example. So how to find a rank of given matrix? Let us see another example. Example number 2. Example number 2. Find rank of the matrix. Our matrix is given order 4 by 5. So first row is 3, 4, 5, 5, 6, 7. Then 4, 5, 6, 7, 8. Third row is 5, 6, 7, 8, 9. And the last row is 15, 16, 17, 18, 19. So total 4 rows are there and 5 columns. So order of matrix is 4 by 5. Now we have to find rank of this matrix. So reduce this matrix to echelon form. So to reduce this matrix in echelon form, we have seen the method to reduce. So very first method we require the entry A11 equal to 1. So for this we are, remember, we are allowed to use only row transformation. So applying row transformation, we have to make this A11 equal to 1. So you can apply which transformation? R1 minus R2. So this matrix is equivalent to 3 minus 4, it is minus 1, 4 minus 5 is minus 1, minus 1, minus 1, minus 1, remaining row as it is 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, last row is 15, 16, 17, 18, 19. If you want, you can apply another transformation minus 1 times R1, but I am not going to apply this. Now my target is to make all entries below this A11 equal to 0 by using row transformation and using R1 row only. So to make this entry equal to 0, so I have to multiply R1 by 4 and then add. So apply which transformation? R2 plus 4 times R1. For this entry, we can apply R3 plus 5 times R1, and for this entry, we can apply R4 plus 15 times R1, and your matrix will reduce to first row as it is minus 1, minus 1, minus 1, minus 1, minus 1 as it is. Now 4 you are multiplying by 4 R1 entry, so 4 minus 4, so that becomes 0. 5 minus 4, that is 1. 6 minus 4, 2, 3, 8 minus 4, 4. Then next you are multiplying R1 by 5 and subtracting for R3 row, so 5 minus, in fact you are adding because minus sign is there, so 5 minus 5 is 0, 6 minus 5 is 1, 7 minus 5 is 2, 8 minus 5 is 3, this 9 minus 5 is 4. Now you have to multiply this R1 row by 15, so 15 minus 15, this is 0, 16 minus 15 is 1, 17 minus 15 is 2, 18 minus 15 is 3, and 19 minus 15 is 4. Now this matrix becomes, and we have got all elements below A11 equal to 0. So next step, go to this A22 and we have to make all entries below A22 equal to 0 by applying row transformation. So which transformation we have to apply? So just subtract. So R3 minus R2. So remember, to make entries below A22 equal to 0, you have to use only R2 row. Don't use R1 row, because once you use the R1 row, these zeros will maybe disturbed. So we have to take care of that. So remember, to make entries below A2 to 0, we can use R2 row only. So which transformation? R3 minus R2 and R4 minus R2. So apply R3 minus R2, right? R4 minus R2. So your matrix, first row as it is, minus 1, minus 1, minus 1, minus 1, minus 1. Then second row as it is. So this is 0, 1, 2, 3, 4. Then these two rows are same, so you will get 0. So you will get 0, 0, 0, 0, 0. Then 0, 0, 0, 0, 0. Matrix. And this matrix is in echelon form. Why? Because in these two successive non-zero rows, the first non-zero entry of lower row, we have to look at the first non-zero entry of lower row and we have to check whether that appear to the right of first non-zero entry of its upper row. So it is there. So this one lies to the right of this minus 1. So you can conclude that which is in, and whenever there are 0 rows, that 0 rows must be at the bottom of matrix, and this holds here. So which is in, you can conclude that echelon form, and therefore rank of matrices, we have not given the name, so you can just put the word rank is equal to 2. So for this matrix, rank is 2. Total number of non-zero rows. This first row is non-zero, second row is non-zero, and the remaining rows are 0, and therefore the rank of the matrix is 2. The next example. So example number 3, and now we will see how to solve system of linear equations. So examine for consistency of the system of linear equation. System is given 3x plus 4y minus z plus 2w is equal to 1, then x minus 2y plus 3z plus w is equal to 2, and third equation is 3x plus 14y 14y minus 11z plus w is equal to 3. So this system we have to solve. So very first step for solving the system of linear equation is matrix form of given system. So you have to write matrix form of given system is. So we have to write the coefficient matrix. So in very first equation, coefficients are 3, 4, minus 1, 2. Then in second equation, 1, minus 2, 3, 1. Third equation, 3, 14, minus 11, 1. So this is your coefficient matrix. Then you have to write the matrix of unknowns. So this is x, y, z, w. So these are unknowns, or you may call this as variables, and equal to column matrix of RHS constant 1, 2, 3. As all RHS constants are non-zero, so this is it is non-homogeneous system of linear equation AX equal to B. Next step, augmented matrix. Augmented matrix is how to obtain augmented matrix. We have to join this column matrix of RHS constant to this coefficient matrix. So first write coefficient matrix as it is. So it is 3, 4, minus 1, 2, 1, minus 2, 3, 1, then 3, 14, minus 11, 1, and we have to join this column to this coefficient matrix. So 1, 2, 3, and now this is your augmented matrix. If you want, you can denote this by square bracket A, comma B is equal to, and now we have to reduce this matrix to echelon form. To reduce this matrix to echelon form. So to reduce this matrix, we require A11 equal to 1. So you can apply interchange of first and second row. So apply R1, 2. So your matrix will reduce to 1, minus 2, 3, 1, 2. 1, minus 2, 3, 1, 2. Second row, 3, 4, minus 1, 2, 1. 3, 4, minus 1, 2, 1, and the last row as it is. It is 3, 40, minus 11, 1, and 3. So we have got A11 equal to 1. Now my target is to make all entries below A11 equal to 0. So which transformation we have to apply? Apply R2 minus 3 times R1 and R3 minus 3 times R1. So this matrix will change to, so R1 row as it is. So 1, minus 2, 3, 1, 2 as it is. Now 3 minus 3, 0. Then 4, minus plus 4, Now you are multiplying by 3. So 2 multiplied by 3 minus 6 and 4 minus of minus 6 is 4 plus 6, that is 10 minus 1 minus 10 minus 9 is minus 10. Then 2 minus 6 is 2 minus 3 is minus 1 and 1 minus 6 is minus 5. Next is 0, 3 minus 3. Now 14 minus 6 minus minus plus, so that will become 20. Minus 11 minus 9 is minus 20. Then 1 minus 3 is minus 2 and 3 minus 6 is minus 3. So this is your augmented matrix. Now we have got all entries below A11 equal to 0. Then go to A22. So while applying transformation, if it is possible to make A22 equal to 1, then you can apply. Otherwise, keep as it is. Our target is to make all entries below A22 equal to 0 by using R2 row only. Now, if you want, you can apply this transformation 1 upon 10 R2, but here you will get 1 minus 1, but at this position you will get a fraction number minus 1 by 10. So remember, to avoid silly mistakes in the calculation, we have to avoid fraction number. So avoid fraction number and apply. I just want, instead of this 20, I want 0. So you can apply R3 minus 2 times R2. So remember, to make entries below A22 equal to 0, you have to allowed to use only R2 row. So first row as it is 1 minus 2, 3, 1, 2 as 0. Second row as it is 10 minus 10 minus 1 minus 5 and then 0. This position 0. Now minus 20. We are multiplying by 2. So minus 20 plus 20 is 0. Then minus 2 plus 2 is 0. Then minus 3 plus 10 is 7. And now this matrix is in echelon form, because in any two successive rows, the first non-zero entry of lower row must appear to the right of first non-zero entry of its upper row. So you can see row number 2 and 3. So this 7 is first non-zero entry of third row and it appears to the right of this 10, and therefore we can conclude that which is in echelon form. So this is your augmented matrix. Now count the total number of non-zero rows. So how many there are 3. Again, you can hide this last column. So if you want, you can write this. And now the remaining matrix is echelon form of your coefficient matrix A. Now count the total number of non-zero rows. Now for matrix A, this last row becomes 0 and only 2 non-zero rows are there, and rank of matrix is 2, and therefore you can conclude that rank of A augmented B is not equal to rank of A, and therefore you can conclude that system is, what is that? System is inconsistent, means system does not have a solution, that is system does not have, that is system does not have a solution. So this is the criteria for inconsistency. Your rank of augmented matrix is not equal to rank of the given matrix. This 2 minus 5 is 7. 2 minus 5 is 7. So remember, To find rank of matrix A, just hide that last column. Why we are hiding this? Because we have obtained augmented matrix by joining this column to matrix A. So if you hide that column, so remaining matrix will be coefficient matrix, and you can count the total number of non-zero rows. So this is the case for a system has no solution. Next example, how we can solve. Example number 4. So we can see Gauss-Jordan method. So apply. How do we use Gauss-Jordan method? Use Gauss-Jordan method to solve the system of linear equation is given x plus y plus z is equal to 1, 2x plus 3y plus 4z equal to 1. The last equation is x minus y minus z is equal to 0. Now, for applying Gauss-Jordan method, we have to reduce the augmented matrix into reduced row echelon form. So very first step, matrix form of given system is. Collect the coefficient matrix 1, 1, 1, 2, 3, 4, 1, minus 1, minus 1. So this is your coefficient matrix A, matrix of unknowns x, y, z, and the column matrix of RHS constant 1, 1, 0. Next step, augmented matrix is. Augmented matrix, you can write this as A, comma B, and you have to obtain this matrix by joining RHS constant to the coefficient matrix. So coefficient matrix as it is 1, minus 1, minus 1. You have to join this RHS constant. So 1, 1, 0. Now this matrix is augmented matrix. To reduce this matrix into which form? Because we are applying Gauss-Jordan method, so we have to reduce this into reduced row echelon form. Reduced row echelon form. We have seen when matrix is said to be in reduced row echelon form. So first reduce this matrix into echelon form. So apply. Now we want entries below A11 equal to 0. So apply R2 minus 2 times R1 and then R3 minus R1. So apply R2 minus 2 times R1 and then R3 minus R1. So first row as it is 1, 1, 1, 1. Next, now you are multiplying this by 2. So 2 minus 2 0. Then 3 minus 2 is 1. 4 minus 2 is 2. So 0, 1, 2. Next, 0, 1, 2. Then 1 minus 2 is minus 1. This is minus 1. Then we are subtracting first and third row. 1 minus 1, 0, minus 1, minus 1, minus 2, minus 1, minus 1, 2, and 0, minus 1. It is 0, minus 2, minus 2, minus 1. We'll check the calculation. 2, 3 minus 2 is 1, 4 minus 2 is 2, 1 minus 2 is minus 1. Then next is subtracting 1 minus 1, 0, minus 1, minus 1, minus 2, and minus 1. Next, make this entry equal to 0. So apply R3 plus 2 times R2. So first row as it is 1, 1, 1, 1, then 0. Second row as it is 1, 2, minus 1. And now this 0, you are multiplying this row by 2. So minus 2 plus 2, 0. Minus 2 plus 4 is 2. And minus 1, minus 2 is minus 3. Now, we have to make this entry equal to not now this matrix is in echelon form. Now we require this matrix into the reduced row echelon form. So echelon form of a matrix is said to be in reduced row echelon form if the column which contains a leading one. So for this column, for this R1 row, this is your leading one, and in this column you have zeros everywhere else. Now in second, now this is leading entry of second row, and in that column we want, except this entry, we want everywhere 0. So we have to make this entry equal to 0. So you can apply which transformation? R1 minus R2. So we will get 1, 1 minus 0, 1, 1 minus 1, 0, 2 minus 1 is, sorry, 1 minus 2 is minus 1, and then 1 minus plus 2, then 0, 1, 2, minus 1, 0, 0, 2, minus 3. Now, we want this entry as 1, so apply. Now we don't have any option to reduce the fraction number, so you can apply 1 upon 2 R3. So your matrix will become 1, 0, minus 1, 2, 0, 1, 2, minus 1, then 0, 0, 1, minus 3 by 2. Now again this R3 row, this is your leading entry, and in that column we want everywhere 0 except this entry. So to make this entry equal to 0, you can apply. I am making the partition here because I want this matrix in front of me. So this entry I have to make 0, so apply in that column. So you can apply R1 plus R3 and then R2 minus 4 times R3. So this matrix will reduce to R1 plus R3. So 1 plus 0. So that is 1, 0 plus 0 as it is, minus 1 plus 1, 0, and 2 minus 3 by 2. So 4 minus 3, and this is 1 by 2. Then R2 row 0, R2 minus 2 times R3, 1 minus 0, that is 3, sorry, this is 1. Then this 2, we are multiplying this by 2, so 2 minus 2, so that becomes 0, and then minus 1 minus 2 times 3 by 2, minus minus plus, so this minus 1 plus 1, that becomes 2, and then 0, 0, 1 minus 3 by 2. Now this matrix is in reduced row echelon form because the leading entry, the column which contains the leading entry has zeros everywhere else. So you can conclude that it is in reduced row echelon form. Now from last matrix, obviously if you want to check the consistency, so here augmented matrix is, rank of augmented matrix is, what is that? It is 3. Rank of matrix is 3, and therefore you can say that this common rank of A augmented B is equal to rank of A equal to 3 equal to number of variables, and therefore given system has unique solution or only one solution. So this is your last matrix. So from last matrix, we have to rewrite the system of linear equation. So this is the coefficient of x, this is coefficient of y, this is coefficient of z, and this is equal to RHS constant. So directly you will get x equal to 1 by 2, then y is equal to 2, and z is equal to minus 3 by 2, and this is the solution of given system. So you might observe that this Gauss-Jordan method is quite easier than Gauss elimination method, because directly we got the solution, so no need to simplify this. So solution of this system is x equal to 1 by 2, y equal to 2, and z is equal to minus 3 by 2. So these are some examples. So you can solve some example at your own. I'm going to give you exercise number 1. Solve if consistent system is two x plus 3y minus z plus 2w is equal to 3, x plus 2y plus z minus 3w is equal to 1, and then 2x plus y minus 6z plus w is equal to minus 2. Second, examine for non-trivial solution. 2x minus y minus 3z is equal to 0, then minus x plus 2y minus 3z is equal to 0, and then x plus y plus 4z is equal to 0. One important remark I'm going to tell you that if Ax is equal to 0 is the homogeneous system, and A is n by n square matrix, then system has only a trivial solution or zero solution. Trivial solution means zero solution if determinant of A is not equal to 0. And second, system has non-trivial solution Non-trivial solution is non-zero solution if determinant of a equal to 0. In that case, uh, the system has infinitely many solutions. So remember this remark. And this is all about system of linear equation. Let us